Alright, so today we're going to talk about complex fractions. So a complex fraction is a fraction in which the numerator and denominator both contain fractions. It's not pretty, I will tell you that. They are called complex for a reason. But we do have some pretty simple steps in order to simplify complex fractions. So first thing you need to do is you need to get a single fraction in the numerator and denominator both. Okay? Then you will set it up as a division problem by multiplying by the reciprocal and then simplify. So let's look at just some normal fractions. So we have 1/2 divided by 3/4. Now notice, the numerator is 1 whole fraction, the denominator is 1 whole fraction. That is step 1. So that is already completed for us. Then we set it up as a division problem. Okay, so it's really 1/2 divided by 3/4, or 1/2 times 4/3. We do the keep, change, flip. So now we just simplify. Whenever we multiply straight across. So 1 times 4 is 4, 2 times 3 is 6. This can be reduced by 2, so you get 2/3. Final answer. Let's look at the second one. Notice now that the numerator and denominator are not entire fractions. So this is where it can get complex. So I want to look at just the numerator. Okay, and I'm going to do my steps off to the side. So 1/3 plus 1. Okay, well this is really 1/1. We want to make this one big fraction, so we need common denominators. So I'm going to multiply this by 3 on top and bottom. So I get 1/3 plus 3/3, which gives me 4/3. Okay, now I look at the denominator. Well, 1 minus 1/4, that's really 1/1. So I want common denominators. I want to get this as one big fraction, multiply by 4 on top and bottom. So you get 4/4 minus 1/4, which is 3/4. So now I have fractions 4/3 divided by 3/4. Okay, so now we do the multiplying by the reciprocal. So I'm going to keep the first one, change to multiplication, and then flip my fraction. So I will get 16/9. So that's how it works with just normal fractions. We're going to go through a lot of examples just so you can get the hang of it. So looking at number 1, again, first goal is that we want a fraction over a fraction. So in this case, we have 1 whole fraction in the numerator, 1 whole fraction in the denominator. So step 1 is already done. Now we just set it up like a division problem. We multiply by the reciprocal. So I'm going to keep 6/xy, multiply by 8x cubed, over 3y. Okay, and so from here, because I am multiplying, this really is just one big fraction. Okay, and so without even multiplying, I can start reducing. Okay, so 6 and 3, both multiples of 3. So 3 goes into 6 twice, 3 goes into 3 once. Okay, so now what we will have is 2 times 8, which is 16. Okay, so I've reduced all of the numbers. Now let's look at the variables. So I have x cubed divided by x. Okay, so if I have 3 on top, 1 in the denominator, I cancel 1, I'm left with 2 in the numerator. Then I have y times y, which is y squared. This is your final answer. Okay, it cannot be reduced anymore. Looking at number 2. Looks a little bit more complicated, but it is nice because we do have the single fraction over the single fraction. So in this case, we can just do a keep, change, flip. So b plus 2 over b squared plus 6b plus 8 times b squared minus b minus 20 all over 1. Now, at this point, it might be good to factor. So b plus 2 does not factor. B squared plus 6b plus 8, so two numbers that will multiply to 8, but add to 6 is going to be b plus 4 and b plus 2. Now I'm just going to go ahead and make this one big fraction. So I have the 1 in the denominator there. B squared minus b minus 20, so two numbers that multiply to negative 20, but add to negative 1. So I'm going to be looking for negative 5 and a positive 4. So now we can simplify. Everything that matches in both the numerator and denominator can cancel. You would have b minus 5 over 1, or just b minus 5. So now let's look whenever they are not whole fractions over whole fractions. So number 3, I have 1 over pq divided by 1 over p minus 1 over q. So the numerator is already one big fraction, but the denominator is not. So I'm going to try to get common denominators, and I'm going to do my work up here. So if I have 1 over p minus 1 over q, common denominators. In this case, you'll multiply each fraction by the other denominator. So I'm going to multiply this one by q on top and bottom, and this one by p. So 1 times q is q, 1 times p is p over qp. So now my fraction is going to be 1 over pq divided by q minus p over qp. Okay, now we do the keep change flip. So 1 over pq times qp is also the same as pq, so I'm just going to keep it the same. And then q minus p. So these are actually the same, they can cancel. So our final answer is 1 over q minus p. We're going to do kind of the same process with number 4. So I'm going to get, that was not a good squiggly there. I'm going to get the numerator as one big fraction. So I'm going to do it up here. So m over n minus 1, technically over 1. We want common denominators. Well, my common denominator is going to be n. So I need to multiply by n on top and bottom. So I will get m minus n over n. That's my whole fraction. This guy I'm going to do down here. So m over n plus 1. Again, common denominator is going to be n, so I multiply by n on top and bottom. So I'm going to do a big division right there. I will get m plus n all over n. So now this is my complex fraction. We do the keep change flip. So m minus n over n times n over m plus n. These n's will cancel. I cannot cancel anything else. M over n divided by, or I'm sorry, m minus n divided by m plus n, nothing cancels. Okay, so this is your final answer. All right, last example. This is the big kahuna. I have a squared divided by a plus 3 plus a squared divided by 5a plus 15, all divided by a divided by a plus 3 plus 1/5. So we need to get one big fraction in both the numerator and denominator. So I'm going to take the numerator and denominator separately. So just looking at my numerator here, if I factor everything that can be factored, which in this case it's just that second denominator, I can factor out a 5 and I get a plus 3. So these denominators have a plus 3 in common. So the first one just needs the 5. So I'm going to multiply by 5 on top and bottom. So this will give me 5a squared plus a squared divided by 5a plus 3. What I've done is I've just smushed those fractions together. So that's my new numerator. So 5a squared, 5a squared plus a squared is really 6a squared. So 6a squared divided by 5 times a plus 3. Okay, so that's going to be my new numerator. Now let's look at the denominator. So a over a plus 3 plus 1 over 5. So this is a case where we have to multiply each fraction by the other denominator. So I'm going to multiply this one by 5 and then this one by a plus 3. Okay, so what I will get is 5a plus 1 times a plus 3 is just a plus 3 over 5 times a plus 3. So simplify this, you can get 6a plus 3 over 5a plus 3. Now let's go ahead and factor this. We can factor out a 3 out of the numerator, which gives us 2a plus 1 over 5 times a plus 3. This is your new denominator. So 3 times 2a plus 1 divided by 5 times a plus 3. Now we do the division. Keep change flips. So 6a squared divided by 5 times a plus 3 times 5 times a plus 3 over 3 times 2a plus 1. So the 5a plus 3's cancel. So we are left with 6a squared divided by 3 times 2a plus 1. So the 6 and 3 can reduce, okay? 3 goes into 6 twice, 3 goes into 3 once. So we are left with 2a squared divided by 2a plus 1. Final answer.